Hello students. So in continuation with our discussions, we'll discuss a topic today, actually a case study. So by now you should know this. What is this joint actually? It's a T joint. So I have discussed this with you. It's a T joint. Since this is in the shape of a L, you can call it as an L joint. Okay. Or you can call it as a corner joint. And if you see this, it is overlapping one over another. So it is butting one over another. So hence it's called as a butt joint. And this joint can be also called as a corner joint. Okay. So these are different types of joints. Other than this, you can do any type of joint here. Okay. So for joining this, what I have to do actually, for joining two metals, what I have to do? I have to do welding. Very good. So can anyone say what are different types of welding available?
Yes, there are mixed welding available and there are gas welding, arc welding, thermal welding, friction welding, laser beam welding, electron beam welding.
Electron beam. Super. So we discussed about arc welding already. So then there is gas welding, as you said. Gas welding is only thing it will be changing is the source of heat. In arc welding, what's the source of heat? Arc welding, what's the source of heat? From where heat will become? Transform. It's a current. Okay, it's current. Gas welding, I'll be getting from gas. Okay, by burning gas. It's similar to your LPG. Okay, so it is actually acetylene. Okay. Then what type of welding you said? Arc welding, gas welding, thermite welding. Thermite welding is actually used for welding railway track. So it's an interesting topic. We'll discuss it later. Then laser beam, electron beam. Those are the things used for welding very, very small components. For your microchip controller, like the small components, we'll be using those things. So that's the kind type of material. Now what material this is? It's actually a mined steel. So any other material, common materials used for welding?
Stainless steel, copper, aluminum, cast iron, and nickel alloys.
Super. So this is a mined steel. Another variation, what you said, it's a cast iron. So it will have more carbon. Other than that, you mentioned aluminium, then copper, then nickel alloys. So these are the commonly used materials used for welding. So now we'll get into our actual case study. So I have 4 plates with me, 4 welded joints with me. What's the problem here is that if you see here, is it is a proper welding or there are some defects available here? Defects available. So what are the common defects available?
You can see that this black.
Okay. 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 So what you said is actually there are blowholes here. I will explain you. Blowholes are nothing but what is that is there will be some holes here. It's actually called as blowhole. What is a blowhole is that when you weld it, if there is an air trap inside, imagine it's a bubble. Okay, there is a metal bubble. Bubble, what happens after a period of time? Will bubble stay or it will burst? It will burst. So when a metal bubble bursts, what will be left is it's a hole there. So that hole is actually called as blowhole. Because we are blowing it and it's blasting. So it's a blowhole. Then there are any other types of defects? Okay. To prevent the welding defects, what we can do is, actually before welding, what I will do is, I will do a process called as filing. So this is actually filed part. This is unfiled part. If you see here, it is actually having some dust particles. But if you see here, it is fully polished. So what I will do is, I will use a filer like this and I will do something like this. What I will do is, if I do this, what happens? The impurities here will be removed. So when the impurities are removed, then porosity will be eliminated. So like this, there are any other prevention methods available for this? Okay. As you have to clean the electrode, then what's the another defect prevention method? Slag inclusion. Okay. What I can do?
Clean the metal of the
Okay. I have to clean the metal. What you said is correct. So I have to clean the metal as well as I have to clean the electrode. So then I can prevent porosity and
use the correct current.
Correct current. You have to use the correct amount of current. Any other points on that? Okay.
Wired high current and rapid cooling and undercuts. I use correct current, keep steady travel time and place the electrode at proper angle.
Okay. What you are saying is that in order to prevent the undercut, I have to use proper current, then I have to use the proper angle and then the proper travel speed. So if you remember the welding, what I did, I have to move the electrode in a correct timing. Okay, if I move it too fast or too slow, what happens is that too much material will be deposited. If I move too slow, too much material will be deposited here. If I move too fast, no welding will happen. So I have to move it in a correct speed in order to get the proper welding. So these are the common welding defects which we can be addressed. Hope this was useful to you. Thank you, Stuart.